Hello everyone. About a year ago, before I got very sick, I designed a sensor that I never got to share with anyone. So I thought here to just show you what the sensor is like. It's very fascinating to know that this actually, by the way, is the old prototype that sucks. I'll tell you why, but the first prototype was actually a lot better. This one doesn't work well, but anyway. A fascinating thing to know is that resistors are almost strain gauges. They're literally almost the same structure on the inside, and what you can do is to place a very cheap and simple to solder resistor and use it as a load cell, or sorry, a strain gauge, which makes a load cell. This sensor is literally nothing, just a few ICs that like read the load cell. There's a small gap between the extruder, which I'll mention why I did that in a bit instead of mounting it together. And that's literally it. This is the expensive hot end that I spend money on and never use because I got sick. Hopefully one day I'll make the new Dude Eternal. I'm gonna use this for because I've been wanting to make Dude Eternal, a new version of the Dude Changer, so bad, and I've been waiting so hard for someone to make a good printer. But H2C is not that good and it's expensive. Index is somewhat decent, but it's expensive. There are just no good printers coming out. The Snapmaker you want is somewhat decent, but it's small and it's not a heated chamber. And I might actually start designing the Dude Changer soon because I've been waiting for someone to do it and nobody's doing it. So anyway, the sensor is pretty cool. By putting the strain gauge here, sorry, the general, I assume that everybody knew this is literally a bed leveling sensor. If you tap it even lightly, it's very sensitive. It will detect that. It has I2C. And it has a little bit of, it also has a separate connection which acts like an end stop. And if you pull it low, it tears it, because before you start tapping it, you have to tear it, because 3D printers are very hot and their temperature varies. So these things are very temperature sensitive. So you have to do it before you do a reading. The other thing this thing can do is actually calibrate and analyze the flow of the hot end. When you push filament through this, what happens is that this thing gets pulled. And this is basically a scale, so it analyzes the pressure inside the hot end. And in theory, I did get very close. What I did wasn't to use a computer program. I literally just looked at the graph, reduced the pressure advance, looked at the graph, and saw that the little bumps are flattening. And it's pretty obvious to think that a computer could do that for you, because it's not that tough of a task to ask it to do. But the point is, this thing can tune pressure advance. But the funniest thing I found is that I couldn't believe it. I'm not sure how sensitive it is, but this thing can detect wet filaments. And the reasoning is very hilarious. I did not expect this, but what happens when you have a wet filament is that it bubbles and bursts and expands. As the moisture in the water expands, it actually pushes back on the extruder as it's pulling in through. So if this was basically, my finger was like the line for the graph, it would look like this as it's extruding. So it would just bump up and down. But with a dry filament, it would look kind of like this, which is hilarious. So this thing can detect wet filament, and I did not plan on it doing this. And yeah, I just wanted to share this is pretty simple. I'm gonna pause the video and see if I can find the functioning proper prototype, because I just was going through my stuff and I found this old bag of printer stuff. I don't even know where I got this from. How did I even get a hold of this? I basically had a bunch of printer parts. I don't have a printer, but I do have a bunch of parts that I used to experiment with this. So I'm gonna show you very quickly. So I found the first prototype, and this one, it's my first ever PCB, kinda actually. I have made some PCBs before. This is a pretty terrible PCB, and it's because it's my first, so forgive this. And the design is horrible. This is what it actually looks like. And you mount the hot end like this to the extruder like this, and you fill this gap with a PTFE tube. I will add a temperature sensor here if I do continue to make Dude, because this is kind of partially for Dude Changer, but I'll probably add a temperature sensor to see if I can compensate for the drift, because if I can't, there's a chance that I might have to switch to eddy currents, which I'm pretty sure is what Bambu Lab started doing actually. I was working on this a long time ago. Seems like they had the same idea I did. So it was kind of fascinating when I saw it. I didn't even know eddy currents were a thing when I was designing this, and I was like, holy crap, you can do that? I mean, to be honest, I knew eddy currents are a thing. I just didn't know you could just use them like that and measure them so precisely. So yeah, this is This is a pretty crappy IC, it's pretty slow. So it makes bed leveling pretty slow, but this is the cheapest, most basic IC I could find, and it's pretty easy to solder and use. So, you know, it's just a prototype. And yeah, this is hot garbage, obviously, but it works very well. I was surprised. And it's insane to think that we have the kind of technology to deflect nanometers or whatever of deflection inside of this thing. Is just nuts to me that we can just do this. But and it's so cheap, by the way. Did I mention you could do it? This thing is barely $2. Like, it's literally using just like $0.5 MOS IC, and this is just the most cheapest microcontroller I could find. And yeah, oh, and the reason this sucks is because, well, to be honest, the design of this actually cancels each other out, the loads, but that wasn't as big of an issue as it was this. The connectors near the load, so anytime you even slightly get near the connector, your readings would all just start jumping around. So in order to use this, you have to clamp your connector somewhere and make sure it doesn't move even just a fraction, because these things are so sensitive that they're going to detect any movement. So this one's pretty stable. This one doesn't have any issues because it's screwed up by here, and this side is kind of levitating and isolated. Just wanted to share this in case somebody wants to try this idea. You can use a resistor as a strain gauge, and that's very awesome and fascinating. And also, this doesn't just have to be a bed leveling sensor. As I said, it can analyze the flow of the hot end. The reason I made this for dudes was the fact that if you have 4 tools, calibrating each of them is a huge pain. You don't want to just stick to the same tool, and even if you do, it's different. And the second is because it can also detect slight movements to the tap as the same twist. So I was gonna calibrate the nozzle offsets with this instead of a camera, because a camera is less reliable, because things could just always block the view, and because a camera is kind of expensive relatively. It's $8 or $10, and you might laugh at that, but these things add up in a tool changer. Although you could argue that, to be fair, that this is $2 and you kind of need one for each tool, but it also does a lot more than just that, just a nozzle offset. And actually I was gonna make another one of these, like this, and it would detect the locking force. It was gonna cost extra compared to the other mechanism, which I have, was literally 2 springs on a block, which this spring it's pretty easy, but I don't want to explain it here, because basically the point of that mechanism is that the spring disengages once it's locked. So it's not, the spring isn't what's holding it, the spring is what's measuring, almost like determining the locking force. But anyway, I just thought I'd give you a quick rant, and that I've been pretty absent. It's because I've gotten very, very sick, and I've also started dedicating practically all of my funds. I mean, I've been trying to do that. It's hard, but I've been dedicating most of the money I get to my surgery, because I'm 26 and I've just realized that I lost like probably most of my life waiting for that surgery. And I don't know. Yeah. Well, either way, I hope you found this interesting, and maybe somebody with a bit more fortunate circumstances could develop this into a proper sensor for everybody else to use.